I'm going to show you how to use Audacity, which is a free download software, to make and to observe beats. The good thing about Audacity is that you can get any two wave functions and it will add them together to show you and then play the superposition of the two. So the first thing I'm going to do is make a track. I will add a new mono track, and I now have to use the generate function to generate a tone, which will be a sine wave. It's a frequency of 440 Hertz. Rather than an amplitude of 0.8, I'm going to change that to 0.5. Now, that doesn't look much like a sine wave. I have to zoom in. So I press that zoom button repeatedly, and you can see that it does look like a sine wave. When I play it, you can listen to what 440 Hertz sounds like. So, next thing I'll do is add another track. So a new track, and I will generate a new tone. Now the first one was 440 Hertz. This one I'm going to make slightly different frequency. So it's 442, still with an amplitude of 0.5. And again, I will see it when I zoom in. So you can see now they look very similar. They're both sine waves. You can see that at the moment the peaks are coinciding, so they're in phase. However, if we looked at more of the wave, we would see that eventually they'd be coming out of phase, and eventually they would be completely out of phase. But I'm going to now select the two of them. So that's the first one. Hold down the Shift key. I select the second, and I'm going to mix and render to a new track, and that will give the addition of the two waves. So the first thing you can see is that it has an amplitude of 1. This is the part where they're in phase, they're interfering constructively, and so I'm getting a wave with twice the amplitude. If I now zoom out, you will see that we get to a point where they're getting out of phase, and when they are perfectly out of phase, they will be interfering destructively, and there will be an amplitude of 0. And so you can see that the sine wave that was the addition of the two has an envelope around it, and that envelope is getting bigger and smaller. Now let's play this. So now you can see that the first wave was 440 Hertz, the second wave was 442, that made a difference of 2 Hertz. So that means that the beat wave should have a frequency of 2 Hertz, and that's what we're hearing. It's getting louder and softer twice a second.